Welcome back, Logan. Do you feel it? The weekend's almost here. All right, so welcome back to another installment of Math from Your Couch. Today we're just gonna revamp, take a look at, sorry, not revamp, but take a look at the quadratic formula one last time. This time I do want to take a look at some more of a little bit more of the analysis portion of it, but still the same exact thing. So the quadratic formula is that story, if you don't remember, that story about that sad boy. So I'm gonna write that down. The story about the sad boy who was unsure, right? Who was unsure about that radical party. Okay, and then he goes to that radical party, but because he is such a square, he loses out on four amazing or awesome chicks. Now this whole thing is over at 2 a.m., so it's all over 2a. All right, and there it is. There's your quadratic formula. It's the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. This is also the quadratic formula for any quadratic equation in standard form. Ax to the power of 2 plus bx plus c is equal to 0. And you're going to want to identify the a, the b, and the c, the quadratic term, the linear term, and then the constant term. Okay, so let's take a look at this. Let's take a look at our first example. Our first example, we have solve x to the power of 2 plus 12x plus 36 is equal to 0. Okay, so the way this works is it's already in standard form, so I'm just going to say a is 1, b is 12, and c is 36. All right, now we use our formula. X equals, now if you remember, I don't plug it in. What I do is I don't just plug it in, I should say. I plug it in and I simplify the stuff I can simplify in my head as I plug it in. So the first thing is we need the opposite of b. So the opposite of b is going to be the opposite of that 12 right there. So we're going to say negative 12. So we're going to go negative 12 plus or minus the square root. B squared, so 12 times 12. B is squared is 12 times 12. That's 144 minus 4, right? Minus 4, and then a times c. 1 times 36. So this is going to be times 36 right there. All right. All over 2a, 2 times 1. I'm not going to write 2 times 1. I'm going to multiply it. I can do that in my head. All right, so now we have x equals negative 12 plus or minus the square root of 144 minus, that's right, 144. And this is where the analysis part that I was talking about comes into play. When you subtract 144 and 144, what you end up getting is 0. So we have x equals negative 12 plus or minus the square root of 0. Now, this number underneath the square root sign, underneath the radical, is what we call the discriminant. And if the discriminant is 0, what ends up happening is we get just one answer. Like, what do you mean, the plus and minus? Yeah, we get one answer because when you get it, the two possibilities are negative 12 plus nothing, right? Negative 12 plus 0, and your second answer is going to be from negative 12 minus 0. And we all know that when you add or subtract 0, nothing happens. So our two answers are going to both come out to negative 12 over 2, which equals just negative 6. So the idea here is that our analysis portion is that if the discriminant, if the number under the radical goes to 0, right, if b to the power of 2 minus 4ac, if that thing goes to 0, then we will have only one solution, like we did in this problem here when 144 subtracted from 144. All right, let's take a look at our another example. Problem number 2. Solve negative 4 plus 6x equals 3x to the power of 2. Now, this problem is just straight wonky. Like, there is nothing good about what's going on here. I want this to be 0, so I'm going to have to get rid of that 3x squared. So I'm going to subtract the 3x squared. And this is where it's goofy. There's nothing to take it away from, right? And normally the x squared goes in the front, so I'm just going to throw that guy out in the front right there. So now I'm going to rewrite it. So it's negative 3x to the power of 2, and then it says negative 4. But we know that the next term should be the x term. So I'm going to write plus 6x before I write that negative 4. So we got plus 6x, so the negative 3x to the power of 2, the positive 6x, and then the negative 4 is equal, and that canceled out to 0, is equal to 0. All right, so all that wonkiness gone, we can now go ahead and solve this thing. To solve it, what we want to do is we want to identify the a, the b, and the c. The quadratic term is negative 3. the linear term is 6, and the constant is -4. All right, now we plug it into our formula. X equals the opposite of b, so -6, plus or minus the square root, b to the power of 2. 6 times 6 is 36. b to the power of 2 minus 4 times -3 times -4, a and c. So I'm going to -3 and -4 is just 12. So I'm going to throw a 12 right there over 2a. Now 2 times -3. So over -6. And then x equals -6 plus or minus the square root of 36 minus -4 and 12 is -48. So we have 36 minus 48. And if you see it, you'll notice something happened in the discriminant. It didn't cancel out to 0 this time. Something different happened. We get x equals -6 plus or minus the square root of -12 minus over -6. And this is beautiful. For those of you that don't like doing math, so pretty much everyone but me, what's going to happen right here is this right here tells us you cannot have that happen. All right, that tells us we have no real solutions. You're not allowed to have negatives under the radical sign. So what this means is anytime there is a single negative under the radical, I'm not talking about up here where you got a -48. I'm talking about when there's a single negative, right? A single negative number, -12. This right here tells me that there are no real solutions. And you could just write that down on your homework. If this ever happens, you can write no real solutions, or you could just say no solutions and be done with it. Now in Algebra 2, you might talk about what the opposite of, or what the other types of solutions are. So if there's no real solutions, what are the other types? But that's something for an Algebra 2 topic. All right, so take a look at the next couple of problems. Try your best. If you have any questions, go ahead and hit me up on email or drop by virtual office hours. All right, I hope you guys have a great weekend. I hope you can experience the outside 6 feet apart from each other. Maybe go out in your driveway, hang out in your backyard, do what you need to do. And I'll talk to you guys next week. All right, have a good one.